K-12 and welcome to the virtual orientation session for A-Level Computer Science at Davenant. My name is Mrs. Theron and I'm Head of Computing at Davenant. The A-Level Computer Science is taught over 9 hourly sessions per fortnight, and you'll have 4 or 5 lessons with Mr. Taylor and the other 4 or 5 with me. We do expect you to be independent and build up your programming skills in your own time, but we're a very supportive department and support is always available should you need it. An overview of the course. The course is made up of 3 units. The first unit, Unit 1, is called Computer Systems, and that will be examined at the end of the course by a written paper. It's worth 40% of the total A-level. You'll learn about things like the characteristics of contemporary CPUs, input, output and storage devices, software and software development, including object-oriented software, exchanging data, which includes things like web technologies, networking and databases, data types, data structures and algorithms, legal, moral, cultural and ethical issues with computer science. Then we have component 2, which is called Algorithms and Programming. That too is 40% of the total A-level and also assessed by a written paper at the end of Year 13. And this covers computational thinking, abstraction, decomposition, problem solving and programming, and writing algorithms to solve problems, as well as standard algorithms. Which brings us on to Unit 3, which is the Programming Project. The Programming Project is worth 20% of the total A-level, and this is non-exam assessment, which means that it's assessed in-house and then moderated externally. And for the project, you will choose a computing problem to work through, and you will analyse the problem, design a solution, and create a solution. You can choose your programming project. We will teach you to program a C# Windows form application with a database. Some students will opt for a different approach. Others will stick with a Windows form. It really is up to you for your preference. There's no right or wrong approach, and either approach can get very high marks. Here are some of the past projects. One student made a mobile app using Java, which changed the wallpaper depending on data from external feeds on a mobile phone, such as the weather. Another student made a trading games application, which took market data from the internet. We had a chess tournament system, a typing tutor, and other past projects. We've had absolutely hundreds of projects. We've been teaching computer science at Davenant for over 8 years, so we have lots of experience. Fantasy football simulator, guitar tuner, guide management system, and many, many more. So how does this compare to GCSE? Some of the topics are built on GCSE and others are completely new. I'm going to show you on the next couple of slides some examples of differences between GCSE and A-Level Computer Science, but it's certainly not a definitive list. At GCSE, you learn to do binary and hex conversions. You learn to do binary shifts. At A-Level, you learn how computers represent negative and decimal numbers in binary. You also learn to do binary floating point arithmetic and masking operations. At GCSE, you learn how various sort and search algorithms sort and search for data. At A-Level, you learn how to implement code various sort and search algorithms. You also learn to measure efficiency of algorithms using big O notation. At GCSE, you write algorithms using the array or list data structure. At A-Level, you move on to learn about more abstract data structures such as stacks, queues, graphs, trees, and hash tables. At GCSE, you need to be able to describe the CPU components for von Neumann architecture. At A-Level, you go on to investigate different architectures and in turn look at the internal workings of a CPU. You also learn to write programs in assembly language using Little Man Computer. At GCSE, you gain an awareness of layers in networking. At A-Level, you get a more depth in understanding of what is happening at each layer. At GCSE, you learn to manipulate databases with SQL. SQL continues with A-level, but you also learn to design efficient database structures using normalization. At GCSE, you learn about the functions of the operating system. At A-level, you learn how these functions work with things like scheduling and interrupts. At GCSE, you have a 20-hour programming task set by the exam board. At A-level, you can choose your own project and language, and it's worth 20% of the final qualification. You can find out more about the course by using our own secure website, which is https://alevelcs.davenant.org. If you're coming from a different school in Year 11, you can use this temporary username in order to access our secure website. The username is y122020@davenant.co.uk and the password is Davenant. There are lots of different very successful careers in computer science. Here's just some of them. Many of our students go on to study computer science at university, and several students also take up degree apprenticeships, meaning that they gain work experience and actually have their degree paid for. The summer task has been emailed to you and is available on the school website, davenantschool.co.uk, if you click on the sixth form section. For the summer task for computer science, it's really important that you use the link that we gave to you in the task in order to sign up. You should then complete the activities that have been assigned to you through the group. This site is written especially for A-level computer science, so there are lots of additional activities on there that if you want to get a deeper understanding of any of the different areas before starting the course. If you're looking for more extension work, improving your confidence with programming will really put you in good stead for your computer science A-level, especially using arrays and lists. And here's three really good sites, highly recommended for you to practice with. W3 Schools is excellent for tutorials. Khan Academy has various short courses for learning about different aspects of computer science. And 101computing.net has some very innovative challenges to really help you delve a bit deeper. They have an excellent section on Python challenges that I'd highly recommend. If you do have any questions, please feel free to get in touch. My email address is tanya.theron@davenant.org. Thank you very much. I look forward to seeing you in September.